Thank you so much. Thank you for having me in UX online series. It's a great pleasure to show something from the field of my expertise. Because today we are going to take a look at the code from another side, because code is the backbone of every software, every website, every app. But what about the coding experience? What about the developer experience? So today we are going to check if we can utilize UX principles to make coding a better experience. And onto the agenda. First, we are going to start with quick refresher on what user experience design is, because we need to set a common ground for our further discussion. Then we will check how we can apply Gestalt principles and Nielsen heuristics, the two most common sets of principles, onto the code to make it more readable. And then we will move to a practical application of the things we have heard to the code. So first, let's start with some numbers. 88%. That's a huge number, isn't it? 88% of users are less likely to return to a site after a bad user experience. And yet, sometimes we are still forcing developers to experience poorly written code. This sounds like a really bad user experience, really frustrating thing. So we are going to talk about UX of code, but as I said previously, we need to set a common ground. So first, we are going to talk a little bit more on UX itself. UX is commonly stated with word user interface. UI. This is the how we should pronounce it. And we need to know what UX and what UI is. We need to distinguish these two fields. So let's start with UI. We often speak of UI when we mean something related to color theory, to typography, to how things animate, and how the visual look and feel of the interface is. And we talk about user experience when we mean the real experience of the product. And often during the design process, we conduct usability tests, we talked with users, sometimes we prepare information architecture. And to prove that this point even more, I have prepared a really reliable example of a ketchup. And yes, this is the UI of the ketchup bottle. So we have this little lid on the top and the stable bottom on the bottom of the table. And the experience of this bottle is as follows. So it's quite hard to get the ketchup out because it is on the bottom of the bottle. So we need to flip the bottle upside down and try to get this ketchup out of it. But what if we change the UI a little bit? So now we have lid on the bottom of the bottle, so it basically stands on the lid all the time, so the ketchup flows down, and it's much easier to get the ketchup out, so we can enjoy our hot dog with ketchup. So this is our common ground, and now we know that UX focuses on the experience, UI focuses on the visual aspects, and we also know that UI may influence UX and vice versa. But what does it have to do with programming even? So now we are going to check the UX of code, because the code is a user interface itself. So let's now imagine following example. Uh, this is your first day at work and you've received the task. You need to refactor some part of code, and this is the code you see. Your first thought is, oh, who wrote that? You don't want to work with this. But after a short time, you need to read what does it mean. And you spend some time and you see, okay, this function is called some stuff. This function returns an error in some conditions. And you can see that there is a 3.14. It probably refers to circle. it may calculate some circle properties or something. So after a while, you will manage to get the meaning of the code. But is this the same situation if everything is on fire, the deadlines are coming, and manager is staring at you because you need to know what this code means and time is passing by? It is not. So we need to fix that code so you can see what does it mean at one glance. And here UX principles come. So UX principles are designed to make sure that the final design meets the needs of the user while providing smooth user experience. And as mentioned in the agenda, this presentation will cover two sets of UX principles. The first one is Gestalt principles, and the second one is Nielsen heuristics for usability. Let's start with the first one. So Gestalt is the word borrowed from German, which means form or shape, and it refers that we perceive parts of something like a whole thing, so an organized whole that is made of some parts. And to give you an example of this occurrence, I'm sure that your brain has filled in all the gaps. So this is how Gestalt principle works. And we have a lot of Gestalt principles, but we are not going to cover all of them. I have chosen four of them because I think that these four are the most significant when it comes to coding. So let's start with the law of similarity. It says that we humans tend to perceive things that are similar as a group. So in this example on the right side, we can clearly see that there is a group of bright dots and we have another group of dark dots, even though we don't have any white space or any other visual grouping. And when it comes to code, we can approach this law in two ways. The first one in this example is that we have two groups of variables. The first one refers to a person that has first name, last name, age, and so on. And the second group refers to some kind of uh, proof, so something related to the account of this person. So for example, max login attempts or the role of the user. And these examples, these variables are written in uppercase. So it basically means that these are global variables. So we have local variables related to the person itself and a group of variables related to the account. But we can also apply a different kind of visual grouping, which comes from our IDE, and we can apply some coloring. So we have another groups of words. For example, we have functional words like cons or other marks, and we have a different color for a variable name. We have first name, last name, and so on, colored in white, and another color comes for variable values. So that is basically it. Let's move to another law, the law of proximity. As I've mentioned before, we haven't seen any visual gap. And here we see a visual gap. So it basically says that objects that are near each other are perceived as a group. We have clearly visible group of bright dots and another group of dark dots. And when it comes to coding, we can do the same thing. We can apply some white spaces to indicate that we have group of variables related to a person, group of variables related to cat, group of global variables, and then we have a block for functions. Also remember to feed your cat if you have a cat. Okay, and for the next law, I have a little quiz for you. So what do you see? A, four Pac-Man staring at each other, or B, diamond in a front of four circles? I'll give you a second to think. And okay, if you have selected option B, I have bad news for you because you are affected by closure law. It says that human tends to fill the blanks to perceive complete objects, even if parts of these objects are missing. So your brain has filled in all the gaps. And in programming, we have these function blocks. What does it mean? It means that for the line number one, on the end of the end of it, we have this curly brace. And in the line three, we have another curly brace. So it indicates a visual boundary that says to us that this is a function. And only among these three lines, we have this function. And then we have white space and the function call. So hello to our audience. Let's move to another law, the law of pregnance. It says that humans tend to see objects in their simplest form. Here we have the logo of Olympic Games, and human eyes tends to perceive this logo as five circles intersecting with each other rather than some lenses, some C shapes or arcs or whatsoever. And in programming, we can see the application of this law for variable names. And here, for example, we have a very long variable name, which is really hard to read. But if we apply some cases, for example, camel case, Pascal case, snake case, it's much more easier to read when we have some visual separations between the words. All glory to the pregnant law. All right, let's now move to another set of principles. We are going now to cover Nielsen heuristic for usability. And this is the set of 10 general principles for interaction design created by Jakob Nielsen. And these are heuristics because they are really general. They do not specify any specific usability guidelines. And my friend once said that we can apply Nielsen heuristic almost to everything, for example, to a coffee mug. So let's now try to apply these principles to a mug filled with delicious dose of morning coffee, evening tea, or in my example, with a water. So let's start with the first one, user control and freedom. So if you take a look at the mug, it's really easy to use. You can see the handle on the side, you can handle it like this, or you can use it with both hands, any way you want. So it's quite easy to use it the way you want. Then let's move to the visibility of system status. So when I look inside, I can see that I have some droplets of water inside, not too much to not spill anything on the table, but it is easy to tell what is the status of the mug. So I know there's not much water and it's probably safe not to spill everything out. Then much between system and real world. So handle is on the side, top is open so I can see what's inside. And almost every mug in the world looks like this, unless it has a lid to not spill things out. But let's say in general that every mug looks the same. So it's easy to tell how to use the mug because every mug in the world looks the same. And every mug on the world, when you put it on the side, I won't do this on live, it will spit its contents out. So this is for consistency and standards because every mug placed on the site will let the contents out. But to prevent that, as I've done a couple seconds ago, I put my mug on the table using the stable bottom so I will avoid spills. Then we have recognition rather than recall. So as mentioned previously, we have this handle on the side. So I know that I can handle this way. So I can travel with this mug to, I don't know, for example, another kitchen or somewhere else. So it's easy to take this with me anywhere else. And then onto aesthetic in minimalist design. So my mug has a variation of this is fine meme, but in Polish. But this graphic doesn't hinder the mug's usability. So I still know how to use this mug, even if it looks like this. And then we have help users recognize, diagnose, and recover from errors. Hot mug still can be handled. So from the visibility of system status, I know that the contents of the mug is cold. But let's suppose that the content is hot. So I can still handle hot mug because it has the handle. I don't need to carry it this way. And on to the last one, help and instructions. If there is any specific method of cleaning, using the mug, probably some instructions will be given in a form of icon on the bottom or whatsoever. For this particular mug, I don't have any icon, so I don't know if I can wash it in washing machine, but I will not try to do this. And let's now consider these heuristics in a perspective of code. So let's think about their applicability to code. And I have divided this heuristic into 4 groups. The first one is code structure and formatting. The second, naming and coding conventions. Third, code efficiency. And fourth, help and documentation. Let's jump into the first one, code structure and formatting. Here we have user control and freedom. So we can, in our code, we can make it work for the typical task. So if I have a task to add something to the code, it should be easy because the code that is already there should allow me to do that. And also in this point, I have mentioned use comments to explain, which is quite a controversial point for developers because some developers don't like putting comments in code because it makes them longer and so on. But from the usability perspective, I recommend to use comments, even if this is a single liner, so the user of your code will know what this function does. Moving on, aesthetics and minimalist design. So in contradiction to use comments to explain, we have avoid clutter and do not overload code with comments. So don't write documentation in code, don't make it very long. But as I said, single liner is just fine. And onto the example, here we have a class for stack. This is a structure that allow you to put in items on and pop them out. And this is basically what this part of code does. Because we have used clear naming, we know that this is stack because we can read that this is the stack, and we don't need to think too much to get the meaning. And we have functions that will allow us to push, pop, and check if the stack is empty. And we have these little comments in line 4, 9, and 14, just to let the user know that this is the function to push items on the stack or to check if the stack is empty, and that's it. Moving on to another category, naming and coding conventions. Here we have match between system and real world. And as said previously, we have known that the stack is the stack because it was named like that. So please use relevant naming to what the function does. And also refer to the real life. For example, if you are going to have a function that, I don't know, for example, counts numbers, let's call it counter or number counter or whatsoever. And then we have consistency and standards. From my perspective, it is important to use consistent formatting that is specific for given language, but also that is specific to your team. And this is something that you have agreed on, because common things or familiar things are easier to understand for us. So it's good to use consistent formatting that we already know. And then we have recognition rather than recall. So these previous heuristics are basically the proof for this one, because when we use meaningful names, meaningful comments, consistent formatting, it is easier to recognize what this part of code really does. And on to the example, we have a class called simple calculator. And as I said, when we have an object in real life, for example, calculator, it probably has functions like adding numbers, subtracting them, multiplying, and so on. So why don't we just name functions inside this class just like that? We have add function, subtract function, and these little comments that explain what the function does. Onto the third category, code efficiency. We have there visibility of system status. And this is quite easy because we can let others developers know what is the status of our code. So for example, if some functionality is missing, we can let others developers know that, oh, there's a to do, we need to add something to this function. And that's it. We can also provide progress or debug messages when you write some part of code that is displaying something in a terminal, and provide clear error messages that will again let us rather recognize rather than recall. Moving on to another, error prevention. And this is all about writing meaningful error messages that should be self-explanatory, and also a bit of preventing them by providing such explanatory messages. So if something breaks, please clearly let other developers know that this breaks because of this and that. And on the flexibility and efficiency of use, we can provide some shortcuts for experienced user, or we can provide code snippets or optimizations that will allow us to write code faster. And onto the example, we have here a mockup function that is called process file. This mockup function processes file, as we know from its name. And here we have this little command in the line number 6 that says, fix me add checks for file extension. So we clearly know that something is missing, and probably what is missing is some if or check for file extension. And we also have console logs in, for example, line 8 that display the status of this function. So we know that at this point of time, this function is reading a file. All right, and on to the last category, help and documentation. We can help users recognize, diagnose, and recover from errors by providing clear messages again, but also by storing logs or writing tests for our code. And also we can have help and documentation because we can use code comments again, but also we can provide some README files. We can use Confluence to store our documentation. And please remember to keep this documentation up to date because there's nothing more frustrating than legacy documentation. And onto the example, this is a really simple example of a README file for our file processor, which explains how to install it and how to use it. And onto the best part, we have this practical application. So if you remember, this was the code from the beginning, this some stuff, and we can quickly fix it by applying similarity law. So now we see some color. It's much more easier for the eye. And then we can keep our users informed by providing some meaningful messages. So when our function throws an error, we can say that, please enter valid positive number. So we now know what happened. And then if we have any logs, we can provide an additional messages like names for the variables that we are going to print. And then we can match our code with the real world by providing meaningful names for our functions. So our function is now called calculate circle properties, and our variables are area, circumference, and diameter. And then if we throw errors, or if we have any other parts of codes that are similar, we can make them more visible by providing some white spaces around them. So in lines 3, 7, 11, and 17, we have just a white space to make code more readable. And then onto user control and freedom, our function was quite long, so we can divide it into two parts. And the first part is for calculating, and the second is for printing properties. So our developer doesn't have to see everything printed on console if he or she doesn't want to. And on to the last one, we can prevent more errors by using types. So for example, if you are using TypeScript, you can define a type called circle properties, which includes every property of your circle. And that's it. This is our before and after of code. And I think the second one looks much better. I hope so. But after this, you may receive a message saying, Ah, Carolina, but your code takes much more space. And that is true. But shorter doesn't always mean better in terms of usability because sometimes we need to take more space to make things readable. However, always consider your project needs because maybe you don't want to your code to be longer than specified number of lines, and that's fine. You can utilize other principles to make your code better. And there is one thing for potential concerns. I've been asked once, should I change AI generated code formatting? And the answer is it depends. It depends because if your team uses a very rigid code structure or something that you have agreed on, I think you should change it. But if this is just for your purpose, you don't use any specific formatting or this AI generated code shows you some way to improve your own code, I think go for it and keep it like that. Some of the main key takeaways, something to remember. First one is write code for humans, not for the machines, because as we have seen, we are affected by different biases, laws, and so on. Second one, provide clear messages, especially error messages, because it's easier to recognize rather than recall what is going in your code. And the third one, embrace documentation and keep it up to date so everyone can refer to it. And that is all for key messages. And that is all from my side. So thank you so much. And I would like to connect with all of you. And I'm open to questions if you have any and if we have any time left.
Thank you, Karolina. That was great. Yeah, please add Karolina to LinkedIn there. If you've got, there's been a few questions, but maybe you can reach out to Karolina directly if your question wasn't asked because we were a little bit tight on time. Interesting question. Someone asked on your team structure and the ratio that you work with.
Okay, so my team is consisting of 4 separate teams, and we have teams for backend, front end, and so on. So my front end team consists of 7 people, I think, but the whole team consists of around 25 persons.
Great, fantastic. And looking at what were some specific results, productivity, what KPIs or metrics were you tracked on to improve this?
Interesting questions because I haven't thought about it. But I think that the key measure is the time spent on beginning the task. We don't actually measure it, but I think this is the interesting one because we can measure the time that you spend on just thinking what you need to actually do. And this is the time we need to shorten.
No, fantastic. Great. Thank you so much, Karolina, for that. Karolina's talk will be available on the website, and you can watch it for the moment on the LinkedIn live stream, as well as obviously the website. Thank you again, Karolina. It was a pleasure,
Thank you.
and thanks for all the insights. Appreciate it.